This lesson we're going to look at the interquartile range. A couple of lessons ago we looked at working out the range from a list of numbers, and last lesson we looked at working out the range from a stem and leaf diagram. The range is used as a measure of spread. It tells us how spread out the numbers in the list are. Whilst it's a good measure of spread, it has its flaws. For instance, using this list here, the range would tell us that if we did the maximum, 59, take away the minimum, which is 1, that the range is 58. The bigger the range, the more spread out the numbers are. However, if you look at the rest of the data in the centre, this is quite closely grouped together. It is just because we've got quite extreme values of 1 and 59 as the minimum and maximum that make it look a lot bigger. So what we do instead is do something called the interquartile range. This looks at just how spread out the central values are. In order to do this, we've got a couple of steps. I'm going to use this same example because this one is already ordered for us. That's the first thing we would need to do for our list of numbers. Step number 1 is to find the median. For this list, the median, the middle number, would be 10. I'm not going to write this down because that's not actually what I'm finding. So circling in this case, even though I said not to previously, is not something that we can that we don't have to do. To find what we call the lower quartile, and the hint there is in the name, quartile sounding like quarter, the lower quartile is quarter of the way through the data. In order to find it from a list, we simply find the middle number of everything that is smaller than the median. So the middle number of the numbers here is 9. So we say that the lower quartile is 9. The upper quartile, this is the number that is 3/4 of the way through the data. That's found in a very similar way by finding what's in the middle of everything that is bigger than the median. So the number that's in the middle of these three here is 14. The interquartile range that we are trying to find finds the range, the difference between the upper and lower quartile. So the interquartile range, which I'm going to shorten to IQR, is equal to whatever number you got for the upper quartile, take away whatever number you got for the lower quartile. So in this example, we would have to do 14, take away 9, which gives us 5. So that tells us how spread out that middle section of data is. This is far more understandable than saying that the data is spread out this much, when clearly it is only the upper amount and lower amounts, so the maximum and minimum. We'll have a look at another couple of examples just quickly. This second example, the first thing we need to do, just as we did with the median, is put the numbers in order. So if we put this in the order 4, 6, 7, 11, 12, 15 and 21. Do make sure you've actually got all the numbers. It's very easy to miss one off, and therefore that will change every single calculation you do for that list of numbers. Step number 1 is to find the median. So the middle number here is 11, which we'll circle. The lower quartile is whatever is in the middle of the data to the left of the median. So here the middle of 4, 6 and 7. It's just here, it's 6. For the upper quartile, we need to find the number that is in the middle of everything that's bigger than the median. So here the middle number is 15. We'll write that down. Final step, the interquartile range. We take the upper quartile, in this case 15, minus the lower quartile, in this case 6, to give us 9. Now this has worked quite easily because the numbers have fallen out very nicely. Let's have a look at one quick example where that isn't always the case. Here we've got another list of data. First step, as before, is to put all of these numbers in order. You can put these smallest to largest, largest to smallest. This way is a little bit easier because then obviously the lower quartile will be to the left of the median. So getting these numbers in order, hopefully a little bit neater in your books than mine, we get something that looks like that. To start off with, we look for the median. So the middle number here, using the same idea as before and going into the centre, the median here is 15. To find the lower quartile, we need the middle number of everything to the left of the median. So in this case, because there are 4 numbers to the left of the median, the middle one is here, in between 8 and 9. So what you would have to do is find what number is halfway between 8 and 9. You can go into decimals for this, so we would get the median here is 8.5. For the upper quartile, we'll do the same thing, so we're looking for the middle number of all of these. Again, it's quite useful to remember our little trick of finding what is between 2 numbers. Here, we need the number that's halfway between 21 and 25. You may be looking at this straight away and thinking it's 23, which is correct. However, if you were looking at it and not sure what number goes in between, so maybe the numbers were a little bit trickier, we could add the 2 together, so 21 plus 25 gives us 46, and then half it, and that tells us what's in between. So 46 divided by 2, 23. Final step then is we can work out the interquartile range. So we would need to do 23, take away 8.5. I will say that you can use calculators if you so wish on this question. That would give us an answer of 14.5. You can now attempt the questions on the worksheet titled Interquartile Range. Make sure that you write all lists in numerical order before you start finding the median, lower and upper quartile.